As a final note on confidence intervals, we can focus on picking our sample size. So we have the power to pick our sample size. In any study we actually conduct, we control how many samples we take. Depending on how bored you are or how committed you are, you can sit and roll a die as many times as you want, flip a coin as many times as you want, ask people a question as many times as you want. This allows us to control the margin of error to whatever level we want. The need for precision varies depending on our question. So if we select a desired ME, so that's margin of error, we can solve for the n. So remember that our margin of error is calculated as z star, or z critical, times our standard error. Here our standard error is square root of pq over n. Now if we just move things around a little bit, so here I multiply both sides by the square root of n, then I divide by the margin of error to get n alone over here. We have z star times square root of pq over the margin of error. Now we can solve for n and get that our n can be calculated for any proportion as our z critical value for whatever interest we have times the square root of p times q divided by the margin of error squared. Now it seems like a complicated equation, and it can be. I'm not expecting you to derive this by yourself. This is in the book, this is here in the lecture notes. You can just come back and find it if you need it. Or in your later life, if you can't find these notes again, you know that this exists and you can Google around to find it. So generally speaking, we can either use an estimate of p hat or 0.5. 0.5 for p hat gives the largest possible margin of error. And it gives the largest possible standard error as well. So that's the safest way to go. For most polling outfits, most polling organizations, or people who want to be really, really sure, they always use 0.5 because it's the most conservative thing they can use. So if we want to calculate a 90% confidence interval with a width of 0.01, so margin of error of 0.01, with an estimated p hat of 0.12, we simply plug those values in here. So our z star is going to come from the normal calculator. This is what we did in the last exercise. Remember, if we mark that last 5%, we can find this z critical value. We plug that in here. We plug in our 0.12, our 0.88, and our 0.01. Okay, run that through a calculator, square it all up, and we get a n of 2857.054. Now an important note here is that every time we do something like this, you always go to the next highest integer. You do not simply round, and the reason for that is that we want a precision of at least 0.01. We want our margin of error to be 0.01 or less, and if we were to round and go to the next lower integer, like would be appropriate here, we might get a confidence width that's just slightly larger than that. So for this purpose only, you always go up to the next integer if you're interested in calculating for a sample size.